I need to get attendance. So Darby's the only one absent. Alright. So, read instructions. Show all your work. And unless otherwise stated, use appropriate significant figures. Put your answer in the box. So, our equation for density. Density is equal to mass divided by volume. So, a mass of 34 grams and a volume of 13.0 cubic centimeters. So, our density is equal to mass divided by volume. So, that would be 34 grams divided by 13.0 cubic centimeters. And so that is equal to 2.615385. And our units will be grams per cubic centimeter. But we need to use appropriate significant figures. This has 2. This has 3. We're doing division, so we use 2 significant figures. So this should be 2.6 grams per cubic centimeter. I took 2 points off for failing to do directions. So let's do this one. So what is the volume? So we're looking for volume with a density of 1.5 grams per liter and a mass of 78 grams. So this class requires algebra. Density is equal to mass divided by volume. We are looking for volume. So to solve for volume algebraically, multiply volume to both sides. Cancels out on this side, so we get volume times density is equal to mass. I did this wrong. And we're solving for volume. Oh, no, I did that right. So volume times density is equal to mass. And now we divide by density. Crosses out. Volume is equal to mass divided by density. Some people didn't do algebra correctly and got this wrong. So again, we start out with density is equal to mass divided by volume. We multiply both sides by volume, so that becomes volume times density equal to mass. And to get volume by itself, we're going to divide by density on both sides. Cancel it out, giving us that volume is equal to mass divided by density. So this is our mass, that is our density. So we plug it in, our mass is 78 grams divided by 1.5 grams per liter. And so this is equal to 52 grams, cancel each other out, leaving us just liters, so 52 liters. Now we check for significant figures. This is in 2 significant figures, this is in 2, and so our final answer should have 2. It does. So our answer is 52 liters. So what is the mass of an object with a density of this? So that is our density, and a volume of 48 cubic centimeters. So again, we start with our original equation. Density is equal to mass divided by volume, and we're solving for mass. So multiply both sides by volume, and we get volume times density is equal to mass. So mass is equal to volume times density. For volume with 48 centimeters cubed times density of 5.7 grams per cubic centimeter. And that equals 273.6 Cubic centimeters will cancel each other out, giving us just grams. Now we check for significant figures. This has 2. That has 2. This is multiplication. So our final answer should have 2. So 270 grams. Which, now that I'm thinking about it, I think I wrote 274 on all y'all. Which is wrong. It should be 270. This would be the correct answer. 200. Oh, that's because I'm rushing. Sorry, trying to run out of time. This says round to the nearest whole number. So we don't use significant figures. We do what the directions say, and we round this to 274 grams. That's the reason why I have 274 on everyone. Read the instructions. This one says to round to the nearest whole number. So the density of lead, so the density is 11.4 grams per cubic centimeter. How much volume would 91 grams? So our mass is 91 grams, and we're looking for volume. So density is equal to mass divided by volume. Solving for volume, volume is equal to mass divided by density. So our mass is 91 grams. Our volume is 11.4 grams per cubic centimeter. And that gives us 7.982456 grams cancel out for the cubic centimeter. And the instructions say round to 2 significant figures. So when rounding, that would be 8.0 cubic centimeter. Everyone good? Alright. 1 milliliter of water has a mass of 1 gram. Ignore everything else temporarily. This says that 1 milliliter of water has a mass of 1 gram. We know density is equal to mass divided by volume. Our mass is 1 gram. Our volume is 1 milliliter. Water has a density of 1 gram per milliliter. Then it asks, what is the density of 253.23 grams of water? Does density depend on size? Is it extensive or intensive property? Intensive, right? Let's see. An intensive property is a property that does not change as the amount of matter changes. So, what would be the density of water in 253 grams? Still 1 gram per milliliter, rounded to the nearest whole number. What is the mass of a liquid with a volume of 58 milliliters? So that's your volume. And its density is 2.4 grams per milliliter. So that's density. Density has a mass and a volume unit. Use appropriate significant figures. So again, density is equal to mass divided by volume. Solving for mass, mass is equal to density times volume. So that's 2.4 grams per milliliter times 58 milliliters. and that's equal to 139.2 milliliters. Will cancel each other out, giving us grams. This had two significant figures, that had two significant figures, so we would round this to 140 grams. Calculate the volume of an object with a density of 0.7 grams per cubic centimeter and a mass of 19 grams. So this is our density. This is our mass. Volume is equal to mass divided by density. Using algebra to solve for it. So our mass is 19 grams, and our density is 0.70 grams per cubic centimeter. And that equals 27.143 cubic centimeters, because grams cancel each other out. And using appropriate significant figures, this has 2, that has 2, we round to 2 significant figures. This is the amount of work you should be showing at the very minimum. So, challenge problems. What is the mass of 34 milliliters of water? We know from problem 5 the density of water is 1 gram per milliliter. We know, also I told you in lab what the density was to begin with. And we have a volume of 34 milliliters. And so our mass is equal to density times volume. So that'd be 1 gram per milliliter times 34 milliliters. Milliliters cancel each other out. And technically it should be 34 grams. The reason why I wasn't going to count off if you put 30 grams versus 34. This is exact. This technically has an infinite amount of significant figures, because this is exact density. And this has 2 significant figures, so it should be rounded. So if I give you something that's exact versus measured things have significant figures, exact quantities don't. So, for example, if I told you there are 24 hours in a day, and I told you that there are there's exactly 60 minutes in an hour, how many significant figures does 60 have? Infinite, because it's exact. If there are exactly 60 minutes in an hour, I should have mentioned this earlier, but make a note of this. Exact numbers i.e. non-measured values, have infinite significant figures. Non-measured values, i.e. non-measured. Sorry for my messy handwriting. So exact numbers, i.e. non-measured values, have infinite significant figures. So example would be there's 60 minutes in an hour. Now if I record something for 58 minutes, I measured that value. I use a stopwatch, or I use a clock, and I measured something to be 58 minutes. 58 minutes has 2 significant figures because I measured it. There's some error on my part. My clock could have been wrong. However, the fact that there's 60 minutes in an hour is a fact. There's no uncertainty about it. Significant figures are used to measure uncertainty. So if I tell you there's exactly 60 minutes as a fact, there's no uncertainty in the number. But if I use a watch to measure roughly 1 hour, then I have only one significant figure. I'm about an hour. It could have took 2 hours. It could have took less than an hour. It's measured. And whenever you're given numbers like this and this, you assume that these are measured quantities. So this problem is tricky because if you're not paying attention, you probably got it wrong. Milliliters and liters. Are these the same units? So for volume needs to match the same units as their density. So our volume is 82 milliliters, which is equal to 0.082 liters. For density is 0.004 grams per liter. And so when determining the mass is equal to volume times density. And so I get an answer of 3.362 times 10 to the negative 4, and this being grams. This had 2 significant, this had 2, so my answer should be rounded as 3.4 times 10 to the negative 4 grams. It says here, use scientific notation with 2 significant figures and units of grams per liter. This is milliliter, so we do the same thing. Volume is equal to 0.106 milliliter. Mass is equal to 44 grams. So density would be equal to 44 grams, and that should be liters. 0.106 liters. And that equals 415.09. And this would be in grams per liter. Now, I don't know why, but every single person who turned in a problem put 420 times 10 to the 2. What is wrong with this number? It should be 4.2 times 10 to the second. First of all, this says use 2 significant figures. And everyone didn't include a point. This is where I would begin to get suspicious of copying going on. Because there is no reason for almost the entire class to make this mistake. One point for incorrect unit, or missing unit, and 2 points for wrong significant figures, and then I didn't take off for the missing point. I should have counted it completely wrong. So I will always take 1 point off for incorrect unit. So, does everyone understand density now? It seemed really easy to me. Well, these were challenge problems. The first 7 set you up to where you don't do any look at units. But the challenging portion here, especially in chemistry, we mix and match units all the time. That's why we're going over dimensional analysis. Every time you're given a problem, check unit. Make sure that when it tells you grams per liter and another 82 milliliters, that these units match. If they don't match, we will have to use dimensional analysis or convert them. How much time do we have in class? I believe now is a good point to mention the code word. Code word is derivative. Code word of the day is derivative. Alright, problem like number 10. So Lake Michigan holds 1.3 times 10 to the 15 gallons of water. It just if just Chicago removed water from the lake and it never rained again, how many days would the water last? If Chicago used 1.2 times 10 to the 9 gallons of water each day. This is probably not a problem that really requires dimensional analysis. But so the question gives us the number given, the main number given is 1.3 times 10 to the 15 gallons of water. And we are looking for days. So we want to get something that's in days. So we need to use some conversion factor that will cancel out gallons of water and give us just days. We have a conversion factor. We have 1.2 times 10 to the 9 gallons of water per 1 day. Or we have that 1 day gives us, we use 1.2 times 10 to the 9 gallons of water. So we want to plug one of these conversion factors in so that gallons of water is canceled. So we would put 1 day, and we put the 1.2 times 10 to the 9 gallons of water on bottom. Gallons of water cancels each other out, and our only unit left is days. So we do this times that divided by this to get your answer. That's all you have to do. Because it is super easy. I mean, like, to me, this is like super easy. Oh, so I don't make an answer key. I just look at your paper and solve every problem on writing it over and over and over again. That's exactly right. I am an answer key. I can just look at your paper and solve it in like a fraction of a second. So, usually, like, I just look at the answer. So again, the whole thing you're trying to do, and why this, I use a grid. They actually use the conversion factors with these parentheses and plug it in. This grid is so useful. It makes the entire problem where you can do these without really thinking too much. You start with what you were given. You were given this number. Then we're going to add conversion factors to it. We'll either add this or this until the only unit left is what we want to have. So, I was just actually doing a little conversion factor in physics. Let's suppose. So here's all I know. I know how to convert between kilometers and meters, centimeters and meters. I know my metric unit conversion. The only two things that I know about metric and imperial units are these two ratios. I have these memorized. 2.54 centimeters is equal to 1 inch. That is my only. This is exact, by the way. The U.S. is metric, even though we don't use it as people. We actually defined our entire units in terms of the metric. This is the definition of an inch. An inch is exactly 2.5 centimeters, or 2.54 centimeters. That's the definition of an inch. I know how many feet are in a mile. Feet in a mile. So this is, and some other things, but these two facts are the only two major numbers I really need to know. So if I wanted to convert 55 kilometers per hour into miles per hour, I do not know the conversion factor of kilometers per hour to miles per hour. So what I would do, this is how I convert it. I set up my dimensional analysis. I do this every time I want to go from kilometers per hour into miles per hour. It's very long, but I don't have to think about it. I know that there's no mistake. Either that or I Google what the conversion factor is. No, I will give you the conversion factor. You don't have to memorize the conversion factors. I will give them one. So, I want to convert kilometers into miles. So, let's start adding some conversion factors. We know that 1 kilometer is equal to 1,000 meters. Kilo means 1,000, so 1 kilometer is equal to 1,000 meters. So I want to cancel out kilometers and get it into meters. So 1 kilometer on bottom, 1,000 meters on top. Kilometers cancel each other out. Now I'm in meters per hour. Meters per hour is my current unit. So I'm not in miles per hour yet. I'm in meters per hour. So again, only thing I know is centimeters to inches. So I'm going to convert this into centimeters. I know that 100 centimeters is equal to 1 meter. So I'm going to convert this into centimeters. So 1 meter go on bottom, so that meters cancel each other out, and 100 centimeters go on top. I'm now in centimeters per hour. You can note that this is a very big number. So now I'm in centimeters per hour. Well, the only conversion factor I have memorized is inches to centimeters, so I'll go ahead and add that in. I want centimeters to cancel out. So 2.54 centimeters on bottom and 1 inch on top. So now I'm in inches per hour. I want to get it into miles per hour. Well, luckily now that I'm in the imperial system, I can now do 12 inches to 1 foot. Now in feet per hour. And now I can go and convert it into miles. There are 5,280 feet per 1 mile. This is how I personally convert unless I Google it. Most of the time I just Google it. But if I don't have Google and all I have is a calculator with no internet, this conversion factor I would do. So this would be equal to 55 times 1,000 times 100 divided by 2.54 times 12 times 5,280. Again, you can ignore the 1. This is technically times 1, but times 1 does nothing. And I get that this is equal to 34.1754. And this would be miles per hour. So you choose whatever number you're given, usually the number within a ratio. Yeah. So the number you're given, you write, oh, I'm given this number right here. So I write it out normally. I want no modification. I don't switch it around or do anything. Yeah. And then these are all conversion factors: 1,000 meters to a kilometer, 100 centimeters to a meter, 1 inch to 2.54 centimeters. These are all conversion factors. 1 mile is equal to 5,280 feet. By the way, significant digits, if I were to use significant digits, these are exact. This is exact. The 1 inch to 2.54 centimeters may not be exact, but by definition, again, you would have to look up, is this exact or is this an estimate? This turns out to be exact. So the only significant digits in this whole problem is this one with 2, so I should technically round this to 34 miles per hour. I don't think, let's see, read your instructions actually. I think I actually told y'all don't worry about significant figures. Yeah, don't worry about significant figures, because that's just more things for me to take off. And the point of this is, one, you really need to learn dimensional analysis, and you don't. It depends. So I prefer 4 or 5 digits. So 1, 2, 3, 4, 5. What I don't like, so unless you're using significant figures, I don't like people doing 3.0123. I don't like people when they just put 3, because this is sometimes very important, especially when the problem asks something like, when the problem said, when the problem gave like 27.007, and so this has 5 significant figures, and then gave another number that is 2.544. This has 4 significant figures. Definitely don't ever use less digits than significant figures required to do it. If it carries, I will accept, like, so 3.333, I will accept if you actually write it precisely. 3.3 carries. If you, this isn't rounding, this is actually just writing the infinite number. So let's look at, so 50 miles per hour to feet per second. So here we're given this number and we want to convert it to feet per second. We begin by writing we identify what our given number we need to convert is. This is the number we're trying to convert. So 50 miles to 1 hour. That's what 50 miles an hour is. Now we need to add conversion factors. We need to get rid of miles and give them in the feet. And we need to get rid of hours and turn it into seconds. So here are the miles. So we know that 1 mile is equal to 5,280 feet. You can do 2 things. One, you can convert these into minutes. So 1 hour is equal to 60 minutes. So, and it's good to, while you're working, actually go and mark off what you're converting. So now hours cancel each other out. So now I'm in feet per minute, and here I would do 1 minute is equal to 60 seconds. So minutes cancel each other out. So 50 times 5,280 divided by 60 times 60. And that's 73.3 carried feet per second. I'm given feet, I'm given seconds. You can also memorize this, it might help. 1 hour is equal to 3,600 seconds. If you just memorize that, you could have converted it differently. So 50 miles in 1 hour. So to convert hours into seconds directly, I put 1 hour, 3,600 seconds. Hours cancel out. And again, you can add these conversion factors in any order. So 1 mile and 5,280 feet. Miles cancel out. So this would be equal to 50 times 5,280 divided by 3,600. And I get 73.3 carries per second. So is everyone good on dimensional analysis? So looking at something like problem 15, 15 tells you that there are projectile travels 3 times 10 to the 3 feet in 1 second. This is a conversion of feet into seconds, so this is a conversion factor, and it asks you about 18 minutes. How many feet or how far will it travel in 18 minutes if this is how fast it travels? So this is what we would start with, because this is relating feet into seconds. So we'd start with 18 minutes, and we're going to want to end up with feet as a top and a numerator. So if I go ahead and add this in, so 1, can I add in 1 second and feet anywhere to cancel out minutes? We need to convert minutes into seconds first. So I'll show you 2 ways you can do this. So I need to have minutes and seconds ready to be canceled out. So I'm going to go ahead and convert this 1 minute to 60 seconds. Alright, I can cancel that out. Now I'm given seconds. So now I can add this in. It is 3.00 times 10 to the 3 feet for 1 second. Now the seconds cancel out and I'm left with feet. Another way you could have done this is start it with what you're given. You're given 18 minutes. Add in your conversion factor, but I wouldn't do it this way. And now I'm in minutes, feet, and seconds, which is an improper unit. I need to somehow get rid of minutes and seconds. So to cancel out both minutes and seconds simultaneously, I would do the conversion factor of 1 minute to 60 seconds. Seconds cancel out, minutes cancel out, and all that sort of thing. Yeah. That's why unless you're going by a factor to another factor, like you're given miles to an hour to feet per second. Here we're given a feet to a second and 18 minutes. You're usually going to start with what isn't a ratio. You usually start with what's not a ratio. And then we're trying to convert these minutes into feet using ratios for the rest of it. This square down here is usually empty unless we're going from a ratio to another ratio. Did I already get the code word? It's going to be very difficult to remember every single day. I give a test every 2 weeks. We're speaking of which, so the lab safety, I counted as a test grade. That was like super easy. Everyone made like really good on it. The test will be Thursday. So the plan for this week is tomorrow I'm gonna go over mold, and Wednesday I'm going to go over and review, and Thursday I'm going to give the test. Unless something happens and I extend it to Friday. So let me actually pull up the test. I don't think I give. I think I give more in this class. The chemistry and the physics class are like the major courses where you need to know algebra and do a lot of work. There are going to be some tests, but there is no multiple guess, where it's like doing your whole homework packet in a 45-minute period. In which case, make sure you understand how to do everything beforehand. But I believe this one's going to be multiple guess. But do note, some of my tests are going to be like literally nothing but pure math. That's it for the day.